Hi everyone, welcome to this video. I'll be covering the topic of electricity. Here I assume that you have done some self-study and I won't be covering all the basic formula in electricity. I will focus instead on the key concepts as well as problem solving. Okay, now let's go to the first key concept in electricity. So here you have a circuit with electromotive force E, and connected in series you have three resistors R1, R2 and R3 with respective voltage drop across each resistance V1, V2 and V3. So the first key concept to remember is that E is equals to V1 plus V2 plus V3. In other words, the voltage E will be dropped across the three resistors and they will all add up to E. The second key concept here is that the voltage drop Vi is proportional to resistance, and this is because of the formula V equals to I times R. Now the third thing to remember is the same current IC, C for circuit, flows through the entire circuit. Now let us look at an example. So in this circuit you have E equals to 10 volts and you have two resistors connected in series, resistance of 4 ohm and 6 ohm. So now what is the voltage V1, the voltage drop across the 4 ohm resistance? So in the previous slide we have learned that Vi is proportional to Ri. So if you apply this concept, you can work out that the voltage drop across a 4 ohm resistance, which I call V1 here, is equals to 4 divided by total resistance in the circuit, 4 plus 6 ohm, times 10 volts. And you will get 4 volts. Now how about V2? So if you apply the same concept, V2 again is equals to resistance R2, which is 6 ohm, divided by the total resistance in the circuit, 4 plus 6 ohm, multiplied by 10 volts. And here you get 6 volts. You can also take 10 volts minus 4 volts, in which case you will get 6 volts. So over here what you should try to remember is that the higher the resistance Ri, the higher will be the voltage drop across the resistance Vi. Now let us look at the potential divider. So potential divider makes use of the concept that the resistance Ri and the voltage Vi are proportional. Okay, now look at this circuit here. The circuit where E equals to 6 volts connected in the circuit. We have a resistor which is divided into R1 and R2. The value of R1 and R2 will change according to the position of this point here, and by varying the values of R1 and R2, you can actually vary the voltage drop across R1 and R2, which is V1 and V2. And why so? It is because Vi is equals to Ri divided by the total resistance in the circuit, in this case is R1 plus R2, times 6 volts, which is the electromotive force. Now here you can see clearly that if we want V2 to be higher, we can do so by adjusting the value of R2. By having a higher value of R2, we can actually have a higher value for V2. Now let's talk about current. How will current choose its path? Now the key thing to remember here is that the lower the resistance, the higher the current. So here you can see there's a circuit. You have a current IC, which is the current of the circuit, and when it reaches this point, it has to split, choose its path. So current IC will split into current I1 across resistance I1, and current I2 will flow across the resistance R2. Now, so here basically we are saying is that the current is inversely proportional to the resistance. So if you are asked to calculate the current in the branch, for example I1 here, it is actually equals to the resistance R2, which is the resistance in the opposite branch, divided by total resistance R1 plus R2 times the current in the circuit. So this is how the current will distribute itself across the two branches. Now let's look at this example here. We have a current in the circuit of 1 ampere, and when it reaches this point, you have to choose its path again. So how is it going to distribute itself across the two branches? Now here you can see that on one branch you have a resistance of 9 ohm, and on the other branch you have a resistance of 1 ohm, and 9 ohm is greater than 1 ohm. So based on what we have learned earlier, you would have expected that the current I1 will be smaller than I2. What is the value of I1 then? So I1 here is calculated by taking the resistance of the opposite branch, in this case 1 ohm, divided by the total resistance 9 plus 1, multiplied by the current of the circuit, which is 1 ampere. And here we will get 0.1 ampere. Similarly, current I2 is calculated by taking the resistance of the opposite branch, which is 9 ohm in this case, divided by the total resistance 9 plus 1 times 1 ampere, which is equals to 0.9 ampere. Now let's take a look at the LDR, which is the light dependent resistor, and the thermistor. So here you have the symbol for LDR and thermistor respectively. So what do we need to remember here? For the LDR, you have to remember that when there's light, the resistance of the LDR will actually decrease. And for a thermistor, when there's heat, the resistance of the thermistor will decrease too. So the reverse is also true. When there's no light, for LDR, its resistance will be very high. And for thermistor, when there's no heat, meaning when there's cold or temperature is low, its resistance will be very high. So in the next few slides, we will look at how we can make use of the LDR to protect our home when our family is away on holidays. And similarly for thermistor, we'll look at an example of how we can use it to turn on heater in cold weather. So here is a circuit involving a LDR on top and a buzzer. And we'll now look at how, when the family is away, we can use this circuit to protect our home against burglars. So when the family is away, you expect the home to be in darkness. So when the home is in darkness, the resistance of the LDR is actually very high. So as a result, the total resistance in the circuit is also very high, and which gives rise to a very, very small current in the circuit. So as a result, the buzzer is not activated because there is almost no current in the circuit. Now imagine if a burglar enters the house and he shines his torchlight on the LDR. This will result in a decrease in the resistance of the LDR. And as a result of that, the total resistance in the circuit decreases. And this gives rise to a huge current in the circuit. And as a result, the buzzer sounds. So this is how we can make use of the LDR to protect your home when the family is away. Now let's turn our attention to the thermistor and how we can make use of it to turn on the heater in cold weather. So this is a circuit involving a thermistor RT here, as you can see. Now we tap the voltage across RT, you see V out here, to connect it to a circuit involving the heater. Now we've learned that V out voltage is proportional to resistance RT. And in this case, V out equals to resistance RT divided by total resistance in the circuit R1 plus RT multiplied by V in. And V in is the input voltage. So what do we want here? We want the heater to turn on when temperature is cold. Now, heater will turn on when V out is high. And this will only happen when RT is high, since V out is equals to RT divided by R1 plus RT times V input, as you can see from this formula above. So when will RT be high? It is only when temperature is low. So you can see very clearly that the heater will turn on when the temperature is low or when weather is cold. Alright, we have come to the end of the video. I thank you very much for your attention. If you will need a face-to-face session with me, feel free to contact me at the email address above. Thank you very much.